This is Lake Provo in Provo, Utah. There's a harbor slash marina to the right and the greater body of the lake to the left. And two jetties come out to protect the area and almost meet right here. So that's the narrowest point. That's where the AquaDams will be installed in order to isolate the marina area so that it can be dewatered and cleaned out. This is a 16-foot tall AquaDam, 210 feet long, and two 8-foot tall AquaDams to be used to support the primary 16-foot tall AquaDam. The two containers in the water are partially filled with soil and are cabled to anchors on shore to act as a wave break for the AquaDam. Unloading one of the 8-foot tall, 70-foot long support AquaDams. All those dangly bits are a seatbelt that we used to secure it as part of the load in transit. But we're on limited space here, so he's putting it on the other side of the excavator. Unfolding the open end of the AquaDam after it's been set up at the top of the berm. Unfolding the starting end, which exposes the open ends of the fill tubes.
Well, I gotta tie it so the whole thing comes.
Hey, do we care about this cable?
I think it's good.
One fill tube of the 16-foot tall AquaDam has been pulled out and straightened over the back of the trailer. And the other fill tube is still here, folded up, and it's going to be pulled out, straightened out here shortly. And the outside sleeve of the AquaDam is tied back to the trailer in several places. We also have control ropes that go underneath the AquaDam. They're tied off to the trailer, they go under the dam, over the top, and back to the trailer to a spool of rope. so that a person holding each rope can stop the AquaDam from unrolling unless we want it to. That helps us control the installation of the AquaDam. Okay, the second fill tube has been straightened out, pulled out, straightened out, and made to look like the first one. And now we're getting ready to start putting discharge hoses into the fill tubes. Both fill tubes have had a discharge hose inserted into them on this side of the bank. Now we're pumping water into both sides of the AquaDam at the same time, causing the unrolled section of the AquaDam to fill with water. Once it fills to an elevation higher than the surrounding water level, it exerts a force on the rolled up section of AquaDam and makes the remaining rolled up section of the AquaDam unroll under the power of the water. To keep control over this process, there are 4 half-inch ropes laid down underneath the AquaDam, tied off to the trailer, laid out underneath the dam. They come out in front of the dam and up over the top and back to the trailer on the other side of the berm, which the trailer is acting as an anchor point. So these ropes will stop the roll from unrolling, allowing a head to build inside the AquaDam. That keeps the AquaDam independent of surrounding water flows and conditions. And then as needed, we put slack on the ropes to let the AquaDam unroll in a controlled way. This is the wave break that they've constructed. It consists of 2 40-foot Connex containers with a strong steel cable anchoring, connecting both containers to each other, and also anchoring the ends of each container to the shoreline with these big concrete blocks. The same thing could be accomplished using an AquaDam instead of these containers, just installing the dam out there that's a foot or 2 higher than the maximum wave height elevation, and that would be an effective wave break. Far faster to install and remove, cleaner, all around better. But this is how they've chosen to do it here, so we'll see how effective it is. One of the ropes is tied back to the trailer. This will stop the roll from unrolling and is building up a head in the main body of the AquaDam. Okay, enough pressure is built up. We're gonna let a little bit of rope out. And let the dam unroll a little bit. Alright, we're slacking off the ropes a little bit, helping the AquaDam unroll so it comes up square to the bank we're just about to meet here. There we go. The AquaDam is stopped just a couple feet away from the far bank. You can see the current that's been created because the pumps are pumping and drawing water. There they are. All right. Yeah, you can go for it.
Thanks for the warning. Hey!
The 8-foot tall AquaDam has been slid off the top of the 16-footer and into the water. Now the hose is already connected. We're tying off the 8-footer to the top of the 16-footer, and we're about to start filling the 8-footer. The 8-footer's in the water. It's hooked up. We are filling up this side first a little bit, so then when we fill this one, it doesn't push it away. It kind of pins this tube between that tube and the 16-foot AquaDam. Helps keep the 8-footer in position right behind the 16-footer so we can offer support to the 16-footer immediately without the 16-footer needing to move to become in contact with the side of the 8-footer. The 8-foot AquaDam is nearly full. The deepest point that it passes through is about 7.5 feet deep. So it really only needs to get about 6 inches higher than the surrounding water level before we consider it full.